So welcome, folks. Welcome to the January 2026 HAL meeting. This is a auspicious occasion because we have our annual treasurer report as part of our bylaws. We have to report on the treasury status to the club membership, and Joel Goodman should be doing that. Although, I don't see Joel on yet, so hopefully he'll be on soon too. And then we also have our elections tonight. Oh, and there's Faith. Hey, terrific. Hello.
You guys hear in the back?
Hi, good evening.
Okay, so we just got started, and can you see my screen?
Yes,
Okay, and I've got it set up so that you should be able to share your screen when you are ready to start your presentation. So,
perfect.
okay. So, again, back to the meeting itself. If I really need a third screen. So let's go ahead and get started. I was making my slides for this month's meeting and noticed that, oh, can we turn the lights down or off? I'm getting a lot of glare, and I think it'll be easier to see the screen if we can do that. Oh, we got a great, I didn't turn around for a while. There's only like 5 people in here when I looked. So yeah, and then we can turn on back on some of these things. Oh, yeah. Then we get a little bit of light. All right, well, we'll see if that's a problem. We can. Oh, thank you, Ken. So it's not a milestone year, but as I was making my slides, I brought up last year's slides where it was the 25th anniversary. So I just figured, all right, I'll just put a 26 in there and let you all know that, hey, we're 26 years old.
You used all your crayons too.
Yeah, that's a cut and paste of some little bitmap I found, and then I pasted it like 15 different times. Anyways, so our agenda for tonight are introductions, and we've already had a couple. So, including Roger, who's up at the North Pole. And is anybody else new who would like to say hello or introduce themselves?
Hey, just joined last month, Tom Layer, moved to the area just recently as well, so always had an interest in space, finally took a leap of faith and bought a telescope for Christmas, so I figured what better way to push myself and start learning and be around other professionals and people who've been doing this for a long time, so happy to be here and happy to participate and learn from you guys.
Welcome. Did you say you have a scope?
I do, yeah.
Okay.
And condolences.
All right, well, I think you'll find that like at some of our our club events, there's just everybody's just really willing to share and help out if you have issues and whatnot. That's really why we're all here, just to commiserate our problems and help one another. I see there's a Jackie. Did you have oh no, that was my mouse. I thought I saw your hand up, but that was my mouse turned into a hand. Anybody online want to say hello? Okay, we'll just get started then. I won't belabor this.
Victor,
Yes.
not sure this communication, but the librarian's not on the agenda.
Oh my goodness. Well, we will put you in right after Crystal. I am so sorry. I meant to send you an email. So you have a book of the month for this month?
Yeah, and in fact, I put something in for the slide.
Okay, well, I'll bring it up.
Yeah.
I'll bring it up. Thank you so much. Usually I reach out to Crystal and we communicate in advance when I'm making the slides, and it slipped my mind this month. You guys are too efficient. I didn't think you'd have it together so quickly.
Well, Victor, you're fired. You can't be president anymore.
All right, so moving on. How do I move on when I'm in this mode? There we go. Okay, the arrow just moved from from introduction to club business. So let's just get on with it. Okay, so Joel, are you online? So as I was mentioning, as part of our, Joel's in the Dominican Republic, and who knows, maybe he has bandwidth issues or something, or he got invaded or something. We'll belay that, and hopefully he'll get on. So I would like to just move straight into our order of business for tonight, our biggest item, which is the election. So if I could just find my thing here, where is it? That's what I like. Okay, so I'm gonna just skip past the treasurer's report and hand it over to Wayne. So do you want to just take the HDMI?
No, it's okay. No,
Okay.
run it from here. Hi, welcome, everybody. Thank you for listening to all my emails and not sending me ugly messages back, spamming you. But tonight we have our HAL election. We got a good turnout tonight, both in the room and online. So I'm trying to figure out how I can show the participants.
Do you want to share your screen through?
No.
Okay.
No. Okay, so next slide.
Yeah, I can show the participants if I
This
can.
is fine. So first of all, I want to start out by thanking last year's board members. These are the people who basically made sure our club had things to do and had people to staff the things that we did, and basically saw to it that our club was successful all year. And so our president, Victor, finishing up 3 years. Now, our first vice president, Jim Tomney. Here. Second vice president, Grace Coventry, who's moved and resigned, but he was on the list, so I put it up there. Thank you. Joel Goodman is our treasurer. Richard, I'm going to think TV is our secretary. And David Stein is our event coordinator. I got my reading glasses on. I can't. Okay. And then we have some appointed members. See them down at the bottom, Stephen Prebitz, Satith. I'm going to apologize. Naliapon, Chris Todd. I apologize for mispronouncing that. Crystal Rowland, Steve Jaworski, and Mike Miller. These are members that are appointed by the board to fulfill important roles within the club, get things done, like our webmasters and observatory director, that sort of thing. So thank you very much. And with that, we can move on to tonight's business, which is our elections for 2026. So the bylaws tell us that if we only have a single candidate for each position, we can do the election by voice vote for the whole slate. So just one vote. And we'll vote by raising hands, so it's not quite voice, but it's harder for the people online to yell at me and get a good count. So we will raise hands if you're here in person, and online, we will virtually raise hands on Zoom. And I want to remind you that only members can vote. Thank you, any visitors who are here and online. We appreciate you being here, but please, only members can vote. And I want to remind the members that family memberships get a single vote. Okay. Thank you. And for those of you online, here's how you can raise your hand on Zoom. At the bottom of your screen, you should see a reactions icon. And if you click that icon, you can then click raise hand, and that should raise your hand until such time you lower your hand afterwards. Okay. So next. So first of all, the bylaws require that we have a quorum, which is defined to be 10% of the memberships. So a family membership counts as one, regardless of how many family members are considered members. So we need, since we have about 360 memberships in the club as of, I think it was January 2nd, we need 36 memberships to be present in order to hold the election. So we need to, first of all, ascertain that we have a quorum. So we'll do this the same rules as voting. Ken's going to help me count, but he's going to count the hands in the room. I'm going to try to count the hands online. And we'll see what we can get out of this. So if everybody will appropriately raise your hands, we'll see if we can't get this. So online.
Look at that.
Whoa, look at that.
All the members,
Bill Vandal.
Oh, my sister.
in fact, I will put me in here, actually, I'll count,
Raising.
I'll count me online. If I can find my picture, oh, there it is, and wow. So of all the members online raised their hands, I'm gonna start taking screenshots. I can remember how,
Oh, I raised my hand.
Windows front screen. And I think, is that it? Not a second window, okay. All right, I got it. So,
That would be a good job.
Okay. They're trying to get the automation.
There's like this thing in Zoom, that if it sees your hand, it raises the hand up.
That's fine.
But it's not liking me. It's too much noise in the background.
David Stein, I don't see your hand up. Oh, please, okay. If you could raise your hand with the Zoom, that would help rather than with video.
Trying to find it.
It says react on my screen down at the very bottom of your window.
You gotta find the little, the menu bar may be floating.
Oh. Okay, well, if you can't just raise your hand, we'll do it. So I have 1, 2,
Oh,
3.
react, there it is. Acknowledge.
22, 23, 24, 25. Okay, I counted 25.
Are you doing a test or did you actually call the vote?
No, this is the quorum.
Oh, the quorum, okay.
Ever volunteer.
I counted 25.
I counted 22 if I include the two of you who were raising.
Okay, yeah, don't count me. Did you raise your hand online? Victor, did you raise your hand online?
No, I can't figure out how to do it.
Okay.
That's sad. I can't.
All right, so I was online, so I counted me, so you're 24 then, right?
I'm quite sure that with 30 people on or 35 people online in the group you have there, we have to have a quorum.
Yeah, Wayne's being thorough.
So I have counted 46 members who have identified themselves. There were some ones online who, I'm not sure if they were members or not, but they didn't raise hands, so. But we got 46, we're good for a quorum.
All right.
All right, next. So the slate of candidates we're going to vote for is on the screen now. So for president, we have Jim Tomney. For first vice president, David Stein. Second vice president, Steve Rifkin. Treasurer, Joel Goodman.
Vanderland. Yes,
Treasurer, Joel
sorry.
Goodman. Secretary, Bill Vinderland. Is that how you pronounce it? Okay. And events coordinator is Jose Urias or Urias. I don't know, I'm not sure how he pronounces it. So that's our slate. We're going to have one single vote for the slate as a whole. And we're going to start, first of all, everybody online, lower your hands. I want to make sure I get a clean count here. Lower your hands, please, online. Okay, I've got 3 with their hands still raised, but we're just going to go ahead. Okay, so no, everybody lower your hands, please, because I'm going to try to do this the easy way. All opposed to this slate, please raise your hand. All opposed to the slate, raise your hand. Okay. I count 3 on board online.
It's only because of the complexity of Zoom.
Probably. But we'll count it as 3, just because that's what was there. And we will call that against as 3 online and 0. That's what I thought. So we have 3 opposed. And
I
finally,
changed my mind.
finally, everybody in favor, please raise your hand. Okay, by near unanimous consent, because this is far more than 3, I declare that this election is done.
Excellent.
Okay,
Congratulations.
Victor, this is Joel. I have finally gotten online. So whenever you need me.
Okay, let's see. Did you have anything
Next slide.
else?
yeah, one more slide, I think. Okay, so thank you to our new 2026 HAL Board of Electors. Directors. We look forward to supporting you in the next year. Thank you very much.
Okay, I'm gonna go back to your stuff now, Joel, if you're ready.
Yes, I am. Well done, Wayne.
Yes. Thank you.
Okay, so go ahead, please.
All right. If you'll share the report so that we can see it on our screen. There you go.
Not sharing.
Oh, I'm not sharing anymore. It says I'm screen sharing.
Yeah, now it's there.
Oh, wait. Now there you are. There you are. I'm sorry.
Okay, so,
Slide.
I'm trying, boss.
Okay. All right. I'm comparing 2020, end of 2024 to end of 25. You can see we had $600, almost $550 more in the treasury at the end of this 2025 than we did at end of 24. And you'll see how that's reflected in the next slide. Whenever you're ready.
My computer's really slow. I clicked
Okay.
already. I don't know what's going on. There we go.
Okay, before we get to the cost, that's showing the, oh, wow, this is really small on
Did
my
I skip
phone.
a slide?
No, that you can see we had at the end of 2024, we had 327 memberships, and now we have 358 memberships at the end of 2025. And next slide, whenever. And here's comparing our expenses and income. If you look over to the right side, in 2024, our income from income mostly, as you can see, was from dues. And last year we had some spending for the observatory. And then if you look at the left side, most of the income was very similar, but the difference from 327 to 356 members. Some people pay for 2-3 years, but you see it was a little bit more in dues, right? And then our major expenses, besides the fixed expenses of liability, our big expenses last year were completing the All Sky camera project at Robinson Nature Center, and there will be some more expenses in that in 2026 as the mounting hardware comes through. But pretty much everything else is a constant expense. The one thing we will not have in 2026, we will not have that $348 mailbox rental, which we have now changed our address away from the UPS, so we don't have that rental cost anymore. So that is my report. If anybody, I don't think there's another slide. If there are any questions, I'm happy to answer them.
Okay, it's time to do Halloween.
Okay, well, there's no questions in the room, so,
Oh, thank you.
I think we have to take a vote to accept the budget for next year.
I think this, you can certainly take a vote, but I don't think it is necessary. I don't think in our bylaws that we do something to accept our treasurer's reports at each meeting, but this is just part of our bylaws is that I present a report. The treasurer presents a report at the annual election meeting. But if you'd like to take a vote, certainly.
Okay, so Wayne, could you do me a favor? I really should have a third screen here with the showing all the Zoom people. If you see an online question, just like you do at home. Okay, thanks. Okay, so moving on with our agenda, we have some announcements and then our featured speaker, and then we'll have our shallow sky highlights and then Astro-Images and sketches, of which there aren't too many this month just because the weather's been so bad. But yeah, that's in the announcements. The book of the month will be in the announcements. I don't have it in the agenda, but we'll do it right after Crystal, in honor of Crystal. Where was I going? I was about to say something. Our theme, our members Astro-Images theme are moons, tiny moons. So we had it was an interesting set. We didn't get too many pictures, but a lot of them were moons. Okay, so moving on. Here is the schedule which our coordinator, David Stein, kind of came up with and the board agreed with for this year. We haven't assigned people yet, but so I think David just started. He sent an email out to the key holders, get ready to pick a date and sign up, which
This is, right?
did I say 25? Yeah, this is 2026. Thank you. I was checking to see if anybody would catch that. I think I use that joke once every year.
Prepared.
Okay, so recent events, we had an impromptu yesterday. Ernie opened up. He's hardcore with the cold. I think Jose went there too. One other upcoming event this coming Saturday is a online webinar. It's not a HAL person, but it came recommended to me by somebody who I think is pretty reasonably with it. So I'll send an email out to the club as well. But here's the website. The title of this talk. I think he's a landscape photographer and does a lot of astro with regular cameras, that kind of landscape plus astro, and as a former National Geographic person or whatever. But I think that this one is going to be talking about things that might be interesting to look for in 2026. So might be an interesting talk. Next, I would like to say congratulations to Crystal, who won a very prestigious award, for a National Aerospace Award for educator, and because of all of the excellent outreach that she does, a lot of which is with and through HAL. So we've acknowledged her before, but she had her ceremony. And Crystal, you want to say anything or?
Sure. I just wanted to say that I thanked the Howard Astronomical League in my speech that I would not have been able to accomplish as much as I did without your guys' support and your participation in many of my outreach efforts. So thank you to HAL for being such a fantastic club in order to encourage our community to have a love of space and aerospace. So thank you to you guys as well.
All right, and so the next is my the Book of the Month Club. So I'm going to take this opportunity to share with you all. Oh boy. Come back. Get here. Can you guys see that? You see in my Google?
Yes. Yes.
So I'm going to go to howardastro.org. And here's our website for anybody who hasn't gone to it. And I'm going to tout it because there was a pretty good chunk of my presidency was devoted to helping marshal all the people who really know what they're doing to get this thing online. So it's actually the old website was thorough and awesome, but I think this brings us into the next generation of web browsers and mobile devices and whatnot. So you can like really quickly, do this, then we have all sorts of stuff up here. But one of the things we have under resources, I don't know what I just did. Resources is HAL Library, and there's Book of the Month. So if you ever want to see all the awesome books of the month that Crystal had selected, I think our web connection is kind of slow. Or I'm not clicking right. So here's, it brings you to her online readable document that has all of the books of the month that she did over the last couple or few years. And if you scroll down to the bottom, we should get to, boy, this is slow. Our new librarian, you didn't see it on the screen because it's not an elected position, it's an assigned position. You didn't see it earlier. But our new librarian, thank you very much for stepping up, is David Ludwikoski. Did I say that right?
Close enough.
And so without any further ado, I'd like to turn it over to you.
I don't know where the best place to stand is, but, hey, go for Brett. I'm Stanley. Oh, that's actually. Dave Ludwikoski, kind of a new member, just joined last year. Hope to get more active with the group, although I got a little bit of a conflict now since we moved to meeting night, so I can't stay very long tonight. But I've been teaching at CCPC Catonsville for the past 23 years, astronomy and earth science, directed the planetarium for the past 11 years. So like you, I found a number of different books over the years that I found fascinating. I took a number of online classes a few years back. And one of the books that we had to, in a sense, evaluate, review, whatever else from one of our classes was The Day We Found the Universe. If you're really into more historical astronomy in terms of behind the scenes and what happened and how different major discoveries came about, this is a really good book to follow. Marcia Bartusiak's a very good author. And like many different stories, she starts out at the end and then goes to all the backstories. So she starts off with the AAS meeting, January 1st, 1925 in Chicago, where Hubble was going to present his first major discovery. The fact that he didn't show up, he was so unsure of his results that he had Henry Norris Russell show up and present it instead. But it goes through the backstory. I've just got a couple of highlights from the review that I did. She puts the events in the context of the day. So this took place during the Roaring '20s. So she puts all the other events that were going on to put you in the scene at the time. And she takes you back in time where things started in the 1880s, beginning of the Lick Observatory in California, the discoveries of James Keeler, going up through Arthur Eddington and Vestal Slipher, the interplay between the different scientists in that. So it goes from the 1880s up to the 1930s and finishes with the Hubble's second major discovery about the expanding universe, which of course shattered Einstein's whole premise of a static universe. Thoroughly engaging, very informative. It's just interesting some of the rivalries that were going on and what was happening, and some of the lesser known people as well. Father Georges Lemaitre didn't get enough credit until recently as far as the Hubble law. And the one thing that she does say, which I kind of like to finish this with, what she puts in her preference. The discovery of the modern universe is a story filled with trials, errors, serendipitous breaks, battles of wills, missed opportunities, Herculean measurements, and brilliant insights. It is science writ large. So again, highly recommend this. It seems like there's a lot of pages, but again, the last 50, 60 pages are more of the notes and references in there, but definitely worth reading.
Thanks.
Thank you.
Is Clyde Tombaugh in there? Does she talk about the day that we found things in the solar system as well?
Not really part of the whole.
I was the youngest.
Okay. Now what do I do? I gotta find my browser. Escape and close. Okay, so great. Thanks for that. And I'll be sure to communicate better. And
Yeah.
sorry you had to run.
That's okay.
But thank you so much for making it.
Sure. See you guys next month.
Okay, so is Jim here? Are you online, Jim? So Jim Johnson, former HAL president, astrophotographer extraordinaire, eclipse chaser, eclipse meeting organizer, generally nice guy. Put together, well, if he didn't put together, I put together, but he recently was featured on the Teleview website there was an article about him and his stuff. So I have the link. It's not like you're gonna follow this, whoa. I am all over the place. Why is that? Okay, there we go. It's not like you're gonna type this in, but if you just go to Teleview's website, you can find it through, if you can navigate down to it. But there's a nice article about him and his imaging, and including a few of his images, which are quite amazing. I think the resolution with which I did the screen grab and cut and paste isn't that great. But anyways, I'd just like to congratulate Jim for being featured on, I mean, it's an honor. This is these guys are one of the premier telescope makers, and so to be featured on there, I think it's quite an honor.
And a couple months ago, he was in Sky and Telescope.
Yeah.
Back pages with that dolphin head.
And they, you know what, I've like 3 times I've had it up already. I didn't put it in here because it seemed egregious, but that's in the article. It's online as well. Okay, so another announcement is that we will have a auction coming up soon. Jim Tomney, who is our upcoming president, is also pretty handy with web things, and he helped, start out, I'll say that Benny Palmer made a very generous contribution to the club in 2025. He's got some equipment that he's no longer using, he donated an entire high-end Astro-Imaging rig with all of its components in very good condition. I'll show them in the next second. So the board was trying to figure out what to do with all this stuff. And what we thought would be best for the club would be to sell it so that we can do some upgrades to the observatory and whatnot. We need some dome work at some point soon. I'll probably be calling for dome work. I've stepped down as president, but I'm hoping to be appointed as observatory director next year, so I'm not going away. But anyways, we thought we would, sell the stuff. And then we said, all right, well, we could put it on Astromart, or we could offer it to the club members at a nice discount. Thinking, do that first and see who's interested and steps up. And then anything that doesn't sell to the club members, we can sell on Astromart later. So Jim put together this nice online auction site, which he had done once before. All of the items are listed at around 40% of retail as the reserve price for the auction, meaning if nobody bids that much, we'll sell on Astromart later for 75% of retail or whatever. So February, keep an eye out. The website is called Rally Up. They will take a little chunk of the proceeds, but it's not significant. And it's it's like an automated platform that once we set it up, we have nothing to do with it. It just comes out and it tells us there's no bias on our part. It just tells us who bid the most. So it'll go live on February 1st and then wrap up on February 12th, which is our February meeting. So it'll be very exciting. It'll be last minute people outbidding people, and maybe not. Yes.
Will you be issuing a list of what this is actually?
Yes, so when the announcement that goes out will point you to the website, and here is the list of what's going to be on the website. So all of these, like these are screen grabs from the website. So the items, along with the starting bid price, and then if you click on view details, Jim set it up with like more pictures. It tells you how many more pictures there are with this one of two pictures, one of two, and there's more information. But they're all in terrific condition. I mean, the big ones are this like very nice refractor, this mount that sells for 3,300 new, and this nice camera and filter wheel with all the filters. So anyways, these are pretty sporty prices, and you know, if nobody's interested, that's great. We just thought we'd offer it out first as thank you to Hal, I guess. So stay tuned for that. That should be coming up soon. Okay, so now without any further ado, I'm going to stop sharing my screen. And if we haven't put you to sleep, Faith, you can start sharing yours as soon as I find the button here.
Yes. All right. Hello, everyone. Let me share this real quick. Let me know if you can see it okay and if you can hear me all right. But here we go. So hi, everyone. Thanks so much for inviting me today. My name is Faith Vowler, and I'm the outreach coordinator for NASA's Hubble Space Telescope. Hubble celebrated its 35th anniversary on April 24th, 2025. And so I'm here to talk about its rich history and the many groundbreaking scientific discoveries that it's made. And thanks so much for being here tonight.
Oh, you know what, Faith?
Yep.
I'm sorry. I forgot to go through my little welcome slide with boy, I'm really losing it here. But it looks like maybe you have an introduction to you on the next slide.
Yeah, I do have a couple. I don't know if you I can still let you share yours if you'd like to.
No, go ahead. I was just going to say that you know, the little bio you sent me was well, I'll just say it. But she's an astronomer, educator, space enthusiast from Michigan, who's worked at NASA since January 2022 as in this role of outreach coordinator for Hubble. She is a University of Michigan graduate, where she has a BS in space science and engineering, with minors in physics and astronomy and astrophysics, and an MS in space science. That's all super impressive, I think. And then she worked in New Mexico as an education specialist at the NRAO and the Very Large Array. I'm an antenna engineer, so I really appreciate that part. I love that place. Anyways, and her hobbies include reading, collecting books, baking, and going to the movies. So sorry, I forgot to say that. But again, welcome.
Oh, yeah, no problem.
We see and hear you perfectly.
Yep. So I'll start off with a little bit of background. Some of it you already mentioned, but I can elaborate a little bit more too. So like you said, I'm originally from the lovely state of Michigan. My hometown is Canton, Michigan, in the southeast. A lot of us Michiganders tend to make our glove with our hands and gesture to the part of the glove that we're from. So I'm from down here. But and I chose to stay close to home to attend the University of Michigan. And like you said, I was in the College of Engineering for undergrad, space science and engineering, astrophysics and physics, and then stayed there at their Rackham Graduate School to do a Master of Science in Space Science. And I finished that in December of 2016. And while I was working on those degrees in the summer of 2015, which was right after graduating undergrad and just starting graduate school, I was very fortunate to get a summer internship here in Washington, D.C. at the Smithsonian National Air and Space Museum. And I was an education intern in their education department's astronomy division. And this was the job that really helped solidify how much I love outreach and how I would like to have a career in it. And actually, until I took this current job at NASA, this internship was my favorite job I'd ever had up to that point. And then, as you said, in 2017, I moved away from Michigan to live and work in the beautiful southwestern state of New Mexico. And I was at NRAO's Very Large Array, or VLA, out in the middle of the desert. And I worked there for almost 5 years as an education specialist. And while I was working there, I got to be part of local and sometimes even national science outreach events, working at tables, doing hands-on demonstrations. And then at the VLA, I would coordinate tours and Saturday events and open houses there, and worked there for almost 5 years until January of 2022, at which point I accepted the job here in Greenbelt, Maryland at the NASA Goddard Space Flight Center as the outreach coordinator on the Hubble Space Telescope outreach team. And I am a NASA contractor, so I work for NASA through a contract company, in this case, Kellogg, Brown and Root, or KBR. I moved here in March of 2022, so I've been proud to call Maryland my home for almost 4 years now. And being on the Hubble Telescope's outreach team means that it's my job to, of course, talk to people and teach them about Hubble, like I'm doing here today. So besides visiting classrooms and doing guest talks like this, I get to travel around a lot to go to events around the country, and not unlike what I was doing at NRAO, get to have tables set up with hands-on activities and do various demonstrations and talk about Hubble there. And I also get to do a lot of local events in the Maryland, Virginia, DC area. And so some of those kinds of things include science conferences, air shows, major astronomy events like Astronomy on the Mall in DC, and the solar eclipses in 2023 and 2024. And I also get to give tours of the Hubble control room to groups that are visiting Goddard. As I'll talk more about later, the Space Telescope Operations Control Center, or STOC as we call it, at Goddard is the only place in the world where you can directly talk to and communicate with Hubble. So of course we do get a good amount of people who want to come see it when they're there. And then Hubble also has a traveling exhibit that moves between different museums every few months. And so I'm the person who makes the schedule for where that's going to go, make sure that it gets there on time. Right now, it's actually being installed at a new museum this week, which is pretty cool. So my job involves a lot of logistics as well. And I'm very lucky to work on a great team of talented people. We've got science writers, video producers, web designers, social media experts, and we all work together to make sure that all of our work comes out great and we're doing a good job representing the mission.
Terrific. A couple of them are HAL members. You know, Ernie's last name? Morse. Ernie Morse, do you work with him?
I don't believe so, but
I'm at Space Telescope Science Institute, so I used to work at Goddard occasionally, but not in the last 10 years or so.
I'm sorry.
That's okay.
Hey, Faith, can you go back one slide for just 1 second?
Sure.
So, because the picture on the left, in the left side in the middle, is the Astronomy Festival in the mall, and that's actually where we met. And you gave me your card, and what was the way we connected to have you come and be a speaker. So I just wanted to say that HAL has also participated in the Astronomy Festival in the mall for the last couple of years, and I hope we do it again next year.
Yeah, that's a great event. That's one of our favorite local events that we get to do every year. All right, so now that you know a little bit more about me, let's talk about the main reason why we're all here, which is the Hubble Space Telescope. So Hubble began its groundbreaking mission in 1990, which forever has changed our view of the cosmos and our appreciation of where we are within it. And 35 years later, Hubble's images and science continue to inspire. And so this presentation will provide a brief history about how the telescope came to be and give an overview of its design, and including a summary of some of the space shuttle servicing missions that we've sent up there, highlight a few of its incredible scientific discoveries, and talk a little bit about its future. So 75 years ago, an astronomer named Dr. Lyman Spitzer envisioned a future for space exploration that would involve putting a telescope up into space. And he's considered to be one of the visionaries behind the Hubble Space Telescope for this reason. And this vision actually came over a decade before the launch of the first satellite, the Soviet spacecraft Sputnik, and also before NASA itself had even been established yet. And so with the publication of his paper in 1946, Spitzer explored the benefits and the feasibility of launching a large reflecting telescope into orbit around the Earth. And his vision and extensive contributions were honored more than 50 years later with the launch of a space observatory that was named after him, the Spitzer Space Telescope. That went up in 2003 and observed infrared light for the next 17 years until it was decommissioned in 2020. And so NASA formed following the launch of Sputnik in 1957. And in 1959, an employee at the young NASA asked an astrophysicist named Dr. Nancy Grace Roman if she knew someone who would be interested in creating a space-based astronomy program at NASA. And she volunteered herself, and NASA hired her only 6 months after the agency's formation. And by 1960, she was serving as NASA's Chief of Astronomy and Relativity. And over the next 2 decades, Dr. Roman devoted herself to the cause of securing congressional approval and funding for a large space telescope, or LST, as it was called at the time. And in 1969, thanks to the efforts of Dr. Roman, Dr. Spitzer, and many of their astrophysics colleagues, the National Academy of Sciences gave its approval for the Large Space Telescope project, and hearings and feasibility studies about how we were going to make this happen continued. And NASA proposed that the lifetime of the space telescope would be 15 years. And with the technological limitations at the time, that implied that the instruments would need replacing periodically, either on the ground or in orbit. And NASA and its industrial partners or contractors brought up the option of developing a vehicle that could go into orbit and return to Earth intact and repeatedly be reused. And this is how the concept of the space shuttle was born. And the thought at the time was that the space shuttle could deploy the large space telescope into space and then reel it back in and bring it back to Earth. And so with this in mind, the telescope was designed from the beginning to fit neatly inside the shuttle's cargo bay. And then in 1975, the European Space Agency, or ESA, joined the project and provided 15% of the funding for the Large Space Telescope by contributing to the solar arrays and one of the cameras that would go on board. And in return, NASA guaranteed that at least 15% of telescope observing time would go to European astronomers. And then in 1977, Congress approved the funding to build the LST, which would be one of the most sophisticated satellites that had ever been constructed. And thanks to her contributions in getting it funded and approved, Nancy Grace Roman is considered to be the mother of Hubble. And now another telescope that's going to be launched hopefully later this year, the Roman Space Telescope, is named in her honor. And so with its official approval, development on the telescope began. And NASA chose out of its various centers, Marshall Space Flight Center in Huntsville, Alabama, as the lead field center for designing, developing, and constructing the space telescope. And it chose Goddard Space Flight Center here in Maryland to be the lead in the scientific instrument design and the ground control for the observatory, which I mentioned a little bit earlier. And the Johnson Space Center in Houston, Texas, and Kennedy Space Center in Florida provided the space shuttle support to get the telescope up there. So in all, dozens of contractors, a handful of universities, and several NASA centers over 21 different states and 12 other countries around the world made this dream of a telescope in space into a reality. And then in 1983, the aforementioned Space Telescope Science Institute, or we call it the Institute, began operations at Johns Hopkins University in Baltimore, Maryland. And the staff of the Institute would evaluate proposals for telescope time and manage the resulting telescope observations. So to this day, NASA Goddard handles the mission ops part of operating Hubble, and the Institute is in charge of the science operations. Now, unfortunately, due to underestimating the cost and the engineering requirements for such a state-of-the-art telescope, the launch date was moved back from December 1983 to the second half of 1986. Plans were made to conduct the servicing missions in orbit to update the telescope instead of grabbing it and bringing it back to Earth each time and refurbishing it on the ground. That allowed it to be more budget friendly by not needing to relaunch it every time. And this was also around this time when the project was renamed the Hubble Space Telescope after astronomer Edwin Hubble to honor his many contributions to astronomy. And by 1985, the telescope was assembled and ready for launch. But sadly, after the Challenger disaster in 1986, NASA delayed all flights for at least 2 years to make sure that better safety improvements and protocols were in place. But the Hubble project was able to use that time to perform additional work on the telescope while it was waiting to go up. So the solar panels were improved since there was new solar cell technology. The aft shroud, which is the larger part of the telescope at the back where the instruments are, was modified to make replacing the instruments during the servicing missions easier. The computers and communication systems were upgraded, and they were able to subject the telescope to further stress tests to prepare it for the harsh conditions of both liftoff and being in space. And so finally, on April 24th, 1990, the Space Shuttle Discovery lifted off from Earth with the Hubble Space Telescope secured inside. And on this first day, Discovery entered orbit around the Earth and performed numerous tests on Hubble while it was still inside the shuttle. And on the morning of its second day in orbit, April 25th, the shuttle's robotic arm lifted Hubble out of the cargo bay, as you can see, and then did a lot more tests on it to make sure that they were to get everything up and running properly. And once they'd done that, the robotic arm released its hold on Hubble to allow it to freely orbit. But Discovery and Hubble then orbited the Earth together in a parallel orbit for about 2 days, just in case there were any problems that occurred that required the astronauts to fix something. And after that, Discovery and the astronauts aboard returned to Earth, and Hubble was ready to start looking at space. So now that I've talked about the background of Hubble, let's move on to talk about the mission itself in the present day. So as I mentioned before, Hubble is an international partnership between NASA and ESA, and it's able to see and record images in wavelengths of light from a little bit of infrared, the near infrared part of the spectrum, the entire visible spectrum, and a good chunk of ultraviolet. And it orbits over 300 miles or 482 kilometers above the Earth's surface. And it goes around the Earth once every 95 minutes, which is roughly 15 times a day. And it's moving at a speed of about 5 miles or 8 kilometers per second, which is about 18,000 miles per hour, fast enough to travel across the entire United States in about 10 minutes. And despite how much more work it is to make a telescope to put in space as opposed to a ground-based one, which I've talked a lot about, of course, this also has a few major advantages, which Spitzer himself acknowledged and pointed out when he was envisioning a telescope like this. For one, this allows us to avoid weather like what I affectionately call the dreaded cloud nebula that can appear across the entire sky on many nights and prevent us from seeing much of anything. Also avoids light pollution. And being above the atmosphere allows Hubble to see about 10 times better than an Earth-based telescope with a similar size mirror, because you avoid the distortion effects of the atmosphere. And in fact, there are many wavelengths of light that just don't make it through our atmosphere at all, which includes some ultraviolet light, including some of the UV that Hubble can see, and anything that's higher energy than that, like X-rays and gamma rays. On the other side of the visible spectrum, a lot of infrared, including some of the infrared that Hubble can see, is also filtered out. So for many telescopes like the Chandra X-ray Observatory, Fermi, and Swift that see gamma rays, and Spitzer and now James Webb that see in infrared light, they have to be up in space to even be able to see the kind of light that they're looking at all. And Hubble also resolves objects about 1,000 times better than the human eye. So if you had the telescope in Tokyo, you'd be able to see two fireflies that are 10 feet apart from each other in New York City. And Hubble itself is about the size of a large school bus and weighs about 27,000 pounds, which is roughly the weight of two full-grown bull elephants. And when it's turning to point at different objects, it moves a little bit faster than the minute hand on a clock. It takes about 14 minutes to go 90 degrees. And so here's a diagram that shows how Hubble is laid out internally and externally. Hubble's primary mirror over here is at the back of the skinnier front tube of the telescope. And it's 2.4 meters or almost 8 feet in diameter. And then the secondary mirror here at the top is 1 foot in diameter. And the observatory is entirely solar powered, so Hubble doesn't have any fuel on board whatsoever, fully electronically powered by the solar panels that make up its distinctive wings here. And so during the half of its orbit, when it's on the daytime side of the Earth, it's directly taking in sunlight and recharging its batteries. On the nighttime side of the Earth, the other 45 minutes, it's using battery power. So repeatedly using its battery, recharging it back and forth as it goes around the Earth. And in the middle of the spacecraft, near the center of gravity, you've got the reaction wheels, which are how it turns. They're electronically powered and operate under the concept of Newton's third law. For every action, there's an equal and opposite reaction. So you turn the wheels one direction to turn the telescope the opposite way. And then they're not labeled on this diagram, but you also have the high precision gyroscopes, or gyros as we call them right around here. And the gyros are able to detect how much Hubble is moving, at what direction, how fast. They float in liquid bromine, which has just the right viscosity or thickness for them to be able to tell, all right, this is how much I'm moving around in the bromine, so this is how much the telescope is moving. And the telescope has 6 gyros. Typical operations would use 3, and the others used to serve as backups, but the gyros eventually wear out and fail. And that's especially because, unfortunately, the gyros are connected to the computers and instruments on board with copper wires. Bromine and copper are 2 elements that don't get along very well. So gradually over time, the bromine would eat through those copper wires, disintegrate them, and break the gyros. So this was a recurring problem that we had for much of Hubble's lifetime. I'll talk about that a little bit more once we get to the servicing missions in the next couple slides. But for most of Hubble's lifetime, it needed 3 gyros working to function. But then in more recent years, we were able to figure out what we call 1 gyro mode. So today, Hubble is permanently in 1 gyro mode, and the other fully functioning gyro is held in reserve as a backup. And so to replace the functionality of those other 2, so instead of using 3, we use 1 and some other instruments on board. That does make Hubble about 12% less efficient because those other instruments are pulling double duty by replacing some of the gyros and doing other work. But in practice, that just means if we used to do like 50,000 observations a year, just to put a random number out there now, it would be 44,000. So a bit less efficient, but certainly that's still better than not having a functioning telescope. And in addition to the gyros, Hubble has 3 fine guidance sensors that act as the pointing and control system and calibrate the telescope and make sure that it stays virtually motionless while it's observing. So to calibrate Hubble, we have certain guide stars that we know the exact coordinates of. So we'll use the fine guidance sensors to calibrate by going to one of those guide stars, making sure it's right in the center of the field of view before we slew to the actual object. To give you an idea of how precise these have to be and how precise the telescope has to be, if you had Hubble in Washington, D.C., and attached a very powerful laser to the side of it, the laser would have to remain steady for 24 hours on the president's head on a dime on top of the Empire State Building in New York City. And then commands and data are sent to and from Hubble by the communications antennas. So when Hubble wants to talk to us here on the ground, it first talks to the TDRS satellite system that's tracking data and relay satellite system. It's about 20,000 miles above the Earth, much higher than Hubble in geosynchronous orbit. And from the TDRS satellites, they then talk to our White Sands facility in New Mexico with radio dishes that transmit and receive at the same frequencies. And then from there, the information is sent to Goddard. We look at the mission ops data, and the science data is forwarded to Space Telescope Science Institute. And when we want to talk to Hubble, we just do those same steps in reverse. And the door on the end of Hubble here was closed during servicing missions, as you can see from this slide that I'll flip back to in a moment. But we wanted to make sure that no dust or debris or anything like that would get in Hubble during the servicing missions, so we would close that. The other thing that we can do with it if we need to is if for any reason Hubble couldn't turn properly because the reaction wheels broke, there's the risk that it would end up pointing too close to the sun at some point during its 95-minute orbit. It's programmed to be at least a little bit more than 40 angular degrees away from the sun at any given time. So if for whatever reason it couldn't do that, we could tell the door to close so sunlight wouldn't get into that tube. Thankfully, we've never had to do that. And Hubble has 3 types of instruments in the back here, the aft shroud, that analyze light from the universe. There's interferometers, which are the fine guidance sensors, and cameras and spectrographs. So our 2 primary cameras are the advanced camera for surveys and the wide field camera 3. And we also have 2 main spectrographs that practice spectroscopy of breaking light down into its separate wavelengths or colors, so that we can study what these objects are made out of based on what wavelengths we do or don't see coming from the object. We can also figure out, based on if the spectrum is shifted towards red shifting or blue shifting, whether it's moving away from us or towards us, and how fast it's doing so based on how much it's shifted. And so we currently use the Cosmic Origin Spectrograph, or COS, and the Space Telescope Imaging Spectrograph, or STIS. And then we also have NICMOS, the Near Infrared Camera and Multi-Object Spectrometer. That's a backup for both the cameras and spectrometers on board. And so now back to this slide. So Hubble was the first space-based observatory that was specifically designed for servicing by astronauts while in orbit. And so you can see here the 6 official NASA mission patches for the original deployment, and then for the 5 servicing missions. And the ability to make these repairs and upgrade Hubble's instruments while in orbit became even more important after we launched it in 1990 and discovered that the primary mirror had a major flaw in it that affected the clarity of our early images. So the mirror is ground slightly incorrectly, less than the width of a human hair off of what it should be. But that meant that far away images in particular, like galaxies, came out very blurry. So this image in this slide was taken during the first servicing mission where we sought to correct this issue. So here's a brief rundown of the major highlights of each servicing mission. Servicing mission 1 was December of 1993, and using the Space Shuttle Endeavour. And this was the first opportunity to conduct maintenance on the telescope. And we corrected for that mirror flaw by essentially putting glasses on Hubble, you might say, to fix the problem. And by correcting for that mirror flaw, future instruments that we've installed onto Hubble, like new cameras and spectrographs, have had these corrections already built into it, including a new camera that we installed during this servicing mission. We replaced the original wide field planetary camera with wide field planetary camera 2. And so doing all of these corrections gave Hubble the much better vision to take the beautiful pictures that it's known for. Then servicing mission 2 was in February of 1997 aboard Space Shuttle Discovery. And this extended the range of wavelengths that Hubble could see by installing 2 new instruments and increased its efficiency and performance. And then what was originally conceived for servicing mission 3 to just be a preventative maintenance mission became pretty urgent when in November of 1999, the 4th out of Hubble's 6 gyros failed. And so this was during the time still when Hubble needed 3 of them to properly run. So it put itself into a dormant state that's called safe mode, where it's basically like, I can't function properly under these conditions. Either tell me something else to do or fix me, basically. And so to bring Hubble back into operation more quickly, NASA split the 3rd servicing mission into 2 parts. And so the most urgent priorities, like replacing the gyros, were delegated to servicing mission 3A, which went up in December of 1999 aboard Space Shuttle Discovery again. And then the parts of the planned servicing mission 3 that could afford to wait a few years, we bumped back to servicing mission 3B. That went up in March of 2002 aboard Space Shuttle Columbia. And this was the shortest gap between any of the servicing missions, only 2 years and 3 months apart. And during this time, astronauts replaced Hubble's solar panels and installed the advanced camera for surveys that I mentioned, which took the place of Hubble's last original instrument on board. And then during servicing mission 4, which despite the name is actually the 5th one, that went up May 2009 on Space Shuttle Atlantis. And you could really think of it like Hubble was reborn after this. We knew that this was going to be the final servicing mission, so we did as many repairs and updates as possible. We replaced WIF-PIC Wide Field Planetary Camera 2 with Wide Field Camera 3, and also put up the Cosmic Origin spectrograph. And we knew we were also going to have to come up with a way to make the gyros last longer, or they would just break after a few years like they had before. So we came up with the idea of coating the copper wire with a thin layer of silver to protect it from the bromine, which worked great. And all the currently functioning gyros that we have on board have the silver coating around the wires. And so the 5th and final servicing mission left Hubble at the peak of its scientific capability. And kind of a cool tidbit about this, too, is that Hubble was originally planned, like I mentioned at one point, to be a 15-year mission. Now it's been more than 15 years just since the last time it was serviced. And so over its long lifetime, Hubble has made more than 1.7 million observations. There have been over 21,000 peer-reviewed science papers that have been published directly on its discoveries, and then those papers have been cited in other papers more than 1.2 million times. And we've observed over 100 million astronomical objects, and every current astronomy textbook includes contributions from Hubble. But even after all of this, after everything that Hubble has seen, it still only looked at 0.1%, 1/10 of 1% of the sky. And so there's still so much left out there in the universe to learn, which is why we're very excited to have other partner observatories that look at complementary kinds of light, both launched in the near past and coming up in the future. So now we can talk a little bit about the science highlights, that the wonderful science that Hubble has done. Be possible to cover all of it here in this talk, of course. So you can think of the following slides as covering a few of its greatest hits, so to speak. So we've regularly observed close to home by looking at most of the other planets in the solar system: Mars, Jupiter, Saturn, Uranus, and Neptune, along with the asteroid and Kuiper belts. And so here are a few discoveries of note there. So we've just about 4 years after launch, Hubble watched as 21 fragments of comet Shoemaker-Levy 9 bombarded the giant gas planet Jupiter. And so this was the first time that we had seen an event like this, with an asteroid running and colliding with a planet like this. And we saw another impact in 2009. We've also tracked Jupiter's Great Red Spot over the years and found that found it to be shrinking. And we haven't just looked at the planets, we've also looked at the moons over the years. So we've found the best evidence yet for an ocean of liquid water under the ice crust of Ganymede, the Galilean moon Ganymede, which is the largest moon in the solar system. And we've also observed gas plumes coming up from another Galilean moon, Europa, which has a subsurface ocean as well. And Hubble helped astronomers calibrate Saturn data from the archives of 4 separate missions, which included Cassini and Voyager. And it's captured brilliant aurorae at the magnetic poles of Jupiter, Saturn, and Uranus. And then as far as the ice giants go, Hubble found a couple small moons around Uranus in 2003 called Cupid and Mab, and detected 2 large outer rings around Uranus as well. And then we expanded upon the NASA Voyager's observations of Uranus and Neptune and found that the dark spots in Neptune's atmosphere disappear and reappear in correlation with the sun's cycle of activity. And we retroactively found a small, faint moon called Hippocamp in images taken of Neptune when we looked at them 10 years later. And then we've observed the asteroid belt between Mars and Jupiter, which has helped shape our understanding of the interactions and compositions between the asteroids there. So we've watched asteroids in the belt disintegrate and collide with each other. We observed a comet we observed an asteroid that looked like a comet. It had comet-like tails of dust. That's this P2013 P5. And we found the first known binary asteroid, which also looks like a comet, shown here on the upper left, which has a long number name, 300-163, 2006 VW139. Yeah, a lot of numbers in there. And then Hubble also captured images of the 2 most massive objects in the asteroid belt, Ceres and Vesta. And that helped NASA better plan the Dawn spacecraft's visit to both of those worlds later. And then Hubble has uncovered and learned more about icy objects in the Kuiper belt in the outskirts of the solar system as well. So it found a moon around an asteroid and another moon around Makemake, which is shown here, the second brightest icy dwarf planet in the Kuiper belt. And Hubble also found 4 previously unknown moons that were orbiting Pluto. This particular one has Pluto and then Charon, which we already knew about, but Nix and Hydra were 2 of the ones that Hubble discovered, along with Kerberos and Styx. And all of the observations that we made of the Kuiper belt was critical in helping plan the New Horizons spacecraft's flyby of Pluto in 2015 and then beyond that. So That includes uncovering 2 potential Kuiper Belt objects that New Horizons could target once it flew past Pluto. And in 2019, it flew past one of them called Arrokoth and got some close-up imagery of that as well. So now we move out of the solar system and into our stellar neighbors in the Milky Way galaxy. And Hubble has observed stars in all different phases of their lives: stellar birth, their adulthood, and their death. And it's observed stars individually, binary stars or trios, or even entire star clusters. And it's viewed the nebulae that form these stars or that result from their deaths. So one very well-known object, of course, is the Orion Nebula, for observing both for naked eye astronomy and for space telescopes. One of the richest areas in the sky to study stellar birth. And Hubble was the first telescope that was able to resolve protoplanetary disks, or proplyds, around stars here. It found nearly 200 stars in the nebula it was able to find proplyds for. And there are other famous star-forming regions that Hubble has looked at as well, many of them, but including the Eagle Nebula and the Horsehead Nebula are just a couple of other particularly famous ones. And along with stars, Hubble has also spotted planets forming or fully formed and orbiting around other stars. When Hubble was launched, there were no confirmed planets outside of our solar system, but Hubble's unique capabilities allow it to explore planetary systems around other stars, including looking at planets' atmospheric compositions. And it was the first observatory to image a forming planet called PDS 70b in ultraviolet light. And since the time that it was launched, scientists have found more than 5,000 extrasolar planets. And Hubble's work in finding initial exoplanets resulted in additional missions that were specifically made to study exoplanets, like Kepler and the current TESS, the Transiting Exoplanet Survey Satellite. And even in the stable adult phase of its life, we can see beautiful photogenic stellar activity, like you see here with the star V838 Monocerotis that rolls right off the tongue. This star looks like it's releasing gas like in a nova or supernova at the end of its life, but that's actually not the case. So it instead released an unexplained flash of just light, like a burst of light that expands outwards, and it works a lot like a cave, like the sound in a cave, where if you shout hello and you hear hello, hello, hello. So all of this gas that you see around the star is here all of the time. We just normally can't see it because it's too dark. But as the light from the star moved further away from it, then it lit up that gas and dust and made it glow. So this phenomenon is called a light echo. And Hubble later captured another light echo around another star called RS Puppis as well.
Can we ask questions while you go, or do you want to wait till the end?
Oh yeah, sorry, I forgot to mention that. So I'm planning on just doing spending maybe 15 minutes doing a Q&A at the end, if that sounds good with you.
Okay, yeah, fine.
And so then when a star runs out of its hydrogen fuel, the path that takes towards its death depends on its size. So it can begin to collapse into either a white dwarf or a neutron star or a black hole, depending on its size, its mass. So when a medium-sized star begins to die, it sheds its outer layers and forms a shell of gas and dust that's known as a planetary nebula. And originally, using ground-based observatories, planetary nebulae mostly just looked like spherical blobs, but Hubble was able to show that these shapes are actually much more varied and complicated than we previously realized. So we see here several particularly famous planetary nebulae, particularly beautiful ones, and of course the main one that you see here much larger is the well-known Crap Nebula. And then astronomers have also used Hubble to study many more galaxies outside of our Milky Way. We study them individually, those that are interacting and merging with each other, and even entire fields and clusters of them, like this image of the Hubble Deep Field. So the Hubble Ultra Deep Field image, rather. So the Hubble Ultra Deep Field contains about 10,000 galaxies total, and was imaged over the course of 11 days, not continuously, just parts of those 11 days. And the patch of the sky where the ultra deep field, or UDF, is located, if you were to hold a needle at arm's length, the head of that needle in the sky fits the entire ultra deep field inside of it. And nearly a century after astronomer Edwin Hubble discovered that the universe is expanding, the telescope that we've named after him continues this study. It made refined measurements to calculate the expansion rate of the universe, known as the Hubble constant. And we've gotten this to the expansion rate to a precision of just over 1%, which we've used to estimate that the age of the universe is about 13.8 billion years old. And about 2 years ago, the James Webb Space Telescope actually confirmed these results as well, just to double check for errors. And Hubble also learned, together with ground-based observatories in 2011, that the universe isn't just expanding, but it's accelerating outwards. And this was a discovery that won the 2011 Nobel Prize in Physics. And something else Edwin Hubble did was pioneer a study of galaxies based on their appearance, and he categorized them into 3 basic shapes: spiral, elliptical, and irregular. And so now his namesake telescope has the sharp view to see the details of these shapes a lot more clearly, like including those of multiple galaxies that are merging, like the antennae here and the mice here. And Hubble found that galaxy interactions and mergers are common, and they contribute to galaxy growth and evolution. And a similar fate is actually in store for the Milky Way and Andromeda when they collide in about 4 billion years. And before Hubble, the existence of supermassive black holes, so black holes between millions and tens of billions of times the mass of the sun, was a theory that we didn't have any conclusive evidence for. But today, post-Hubble, we know that supermassive black holes lie at the heart of nearly every galaxy. And they're related in size to their host galaxies. Basically, the larger the galaxy, the larger the black hole. So it seems that they may evolve together with their galaxies. And so gravity acts as a lens, magnifying and distorting space and time in a way similar to an optical lens, like in eyeglasses or contact lenses. So when you have very massive objects like galaxy clusters or collections of galaxies all bound together by gravity, that can cause a gravitational lensing effect, as you see in this picture here, that allows us to see objects that are directly behind the cluster. And as the light passes through a gravitational lens, it can take different paths and produce multiple images of the same object. We see that here with a supernova called Refsdal, where gravitational lensing caused it to appear 4 times. And then more than 80% of the universe is stuff that we can't directly see at all, which we have dubbed dark matter for that reason. And instead, we have to detect it by the gravitational influence that it exerts on light that we do see. And when Hubble looks at galaxy clusters with gravitational lensing and warped background galaxies behind them, they can reverse engineer those distortions to make mathematical models and figure out where the dark matter is concentrated. So where you see the purple here is rather than being something we can actually see, this is a mass map of dark matter showing in a galaxy cluster called Abell 1689 that is 1689 that is based on these mathematical models showing the concentrations of dark matter. Woo. So now that we've seen a lot of pretty pictures that were created by Hubble, we can wrap things up. Overall, Hubble's still in great shape. And we have many redundancies built into it in case of failure. So it's like, oh, if this breaks, well, we've got 2 of them, so we can use this instead. Or, oh, if this thing's not working, then we can use these other instruments instead. And so already it's more than double its expected mission length. So like I said, 15 years was the original. Now we're at 35 and counting. We're pretty confident that Hubble can go at least until the end of the decade and hopefully into the 2030s. And we're excited to have our current partners, new and old, helping us observe, like Chandra, Tess, and James Webb, and are very excited to have Roman joining us as well. But in the meantime, Hubble is still the best space telescope that we have up there right now for both visible and ultraviolet light in particular. And so it will continue doing its great work. And for more information on Hubble, and if you want to enjoy the many web apps, online activities, more images, ebooks, everything else, you can go to nasa.gov/Hubble. And Hubble is on Facebook, X, and Instagram social media accounts. You can find our videos on YouTube and many other images in various Flickr albums. All right, so I'm going to hit the end slideshow button here, but thank you, everybody. Or I guess I might still be sharing my screen, but can you still? Okay, there we go. Let's stop sharing. So yeah, thank you, everyone. And now we can spend the next few minutes doing questions, however much time you feel we've got time for, Victor.
That was just terrific. Thank you so much. That was so thorough and fun.
Thank you.
I have a question. Anybody, I was going to ask about, I'll start it off, I guess. The time lapse of the Echo star. What was the time period over which that, and is there a sense of scale? I guess that light was moving at the speed of light then. It wasn't gas moving.
Yes, I don't have it right up in front of me right now. I believe it was over the course of a few years. That image is online. I'd have to go look it up. I can always email you afterwards with the exact numbers. But yep, they took it, like, I think each individual one was several months. And so all of them together were over the course of a couple years.
Cool. Thank you.
Yeah, I have a question. The Hubble looks a lot like the KH-11 spy satellites. Was any technology used from that program used to design Hubble?
Which telescope is that?
KH-11 spy satellites. If you look at those, they look a whole lot like Hubble. And I'm just curious if any of the technology from that program was used to help build Hubble itself.
You know, that's a good question. I'm actually not sure. I haven't heard anything about that. I'm not sure if those were also launched by the space shuttle as well. So if it was something that also needed to fit in the space shuttle, that could be another reason why they look alike. But I don't know too much about those satellites in general, so I'm afraid I can't say.
Okay.
Anybody else?
I
Yes.
have a quick question.
Go ahead.
So the funding stream for continuing to run the program, it's hard to get money out of Congress. How are you doing with that?
Well, luckily, Hubble isn't as expensive as some of the other missions. Typically, it runs on about $93 million a year. Luckily, it's looking like for the next year, in the most recent appropriations bill that just came out, I think at the beginning of this week, actually, Hubble was one of these specifically named missions that Congress intends to fund for another year, getting the same amount of money that we've previously gotten. So a lot of times when Hubble is when Congress is making these appropriations to various teams or missions, they'll give a certain amount of money to like a directorate, like heliophysics gets this amount, astrophysics gets this amount, etc. And then some of that money, they'll specifically be like, okay, so out of the money that we're giving astrophysics, we want you to give James Webb this much of it and Roman this much of it. And if there are missions that aren't specifically mentioned in there, then the astrophysics division can give them money, but that's at their discretion. Luckily, Hubble was one of the missions that was specifically mentioned as getting the same amount. So, which is great news for us, of course. So we, because we are a government agency that's part of the executive branch, we, NASA, aren't directly like allowed to lobby Congress for that money, but we have many of our partners like the Space Telescope Science Institute, other astrophysicists at various universities and in the field can be like, hey, you really should fund Hubble or James Webb. Like, these are all the reasons why this is a good use of your money and why we want you to continue contributing to this. And because Hubble is in such great shape, then so far it's like, yep, it's benefits the scientific community to keep funding it, especially since we don't have any mission that's going to go up anytime particularly soon that can replace Hubble's visible and ultraviolet observations, at least. So I mentioned before it does some infrared observing, and so now we've got James Webb and we will have Roman, and those are infrared telescopes too. So Hubble doesn't do as much infrared observing these days because those are things that James Webb and Roman can do, but still the best for visible and ultraviolet. So here's hoping that they continue feeling that way, but for at least for now, there's still good vibes in Congress about Hubble, thankfully.
Great, good answer. There's one or two core questions in the room, and I think one online, but then I want to move on. Maybe can you stay on, and maybe at the end, if there's time, field a couple more questions, or do you need to roll?
I can stay for yeah.
Yeah. All right. Well, go ahead, Jim.
Just a clarification, the slide of the black hole, that was the artist rendition, right?
That was what? Sorry?
It was an artist rendition?
Yes, correct.
Not from Hubble. Okay.
Yes.
We had a guy in the club on the Discord group post a picture of ton 618 not too long ago. I mean, for our ground-based amateur, it's just a point of light. But we had somebody take ton 618. I thought that was cool.
Is that an asteroid?
It's a it's I think it's one of the most massive black holes that they know of. Sorry, another question?
What's the best avenue as far as requesting a tour to go down the space flight center, like bring my daughter down there, something like that?
I have to think about who the email is, because you would request a tour. Well, there is the visitor center, and if you go there just at the General Goddard Visitor Center, that's open to the public. I don't think it's open on Mondays, but every other day of the week, anybody can go there. They've got a gift shop. In terms of requesting a tour, I'd probably have to find whose email it is. I do have to say, just because of the a lot of the the buyouts that not just NASA but many other agencies did last year for like the deferred resignation. We did have some of our civil servants take that and had some consolidation of the workforce. So I would have to find like, okay, whose email is it now? Like, I might know who it used to be, but have to figure out who it is now for that. But I'm not sure if they have like a group size limit, but if nothing else, you could definitely at least go to the visitor center. But that is another thing that I could always email Victor if I find it, and he can.
Well, I'll follow up on that.
Thank you.
One online question?
Yeah, we had one online question. Is it possible to upgrade the Hubble and keep it going, or to increase its capabilities? Thank you, Juan, for the question.
Unfortunately, not right now. So, as I believe Alan mentioned in the comments as well, so the space shuttle program was decommissioned after 2011. So currently, we just don't have spacecraft that are going up in space that would be able to easily do that. It is something that's been potentially talked about, like, oh, could we do that in the future, and done feasibility studies for it. Right now, we don't currently have any plans for that. Luckily, during the final servicing mission, again, servicing mission 4, despite being the 5th one, that was when we knew that was probably going to be it. So we're like, all right, anything we want to do, we are going to get it done now. So if we could get a 6th servicing mission somehow in the future, that would be a bonus, but it's not something that we're planning on at the moment. but maybe in the future, because Hubble does eventually get lower in its orbit. So at some point, we're either going to have to push it up or catch it and bring it back down to Earth. We don't want something the size of Hubble just plummeting down through the atmosphere, but we shouldn't have to do something about that until at least the 2030s, possibly later. So we have time to figure out what we're going to do. Maybe that would turn into a servicing mission, maybe not. It just kind of depends on how Hubble's still doing at that point.
Any other online? Okay, so I think we can maybe there might be a couple other questions, but I like to move on and then maybe come back if at the end if we could. But we don't have too many slides. It wasn't a great month for Astro-Images with the weather. So anyways, I'd like to ask another round of applause for Faith. I think that was just I'm gonna go home and try to. I have teenage daughters. I probably won't be successful, but I'm gonna try to have them watch the video of this. I think it's so good.
Thank you, and thanks again for inviting me. I really appreciate it.
Yeah, no, this was really nice. Okay, so moving on with our regular stuff. Next up is Jim Tomney with his shallow sky highlights.
Okay, so we only really have two planets right about now. Saturn is heading into the west, into the solar glare. It'll be in solar conjunction at the end of March. So get your observations in now if you want to see Saturn. Target it as soon as it kind of emerges from the twilight, because it'll be higher in the sky at that point. The last two remaining Titan transits are happening in January, with the event already in progress as soon as the planet becomes visible out of the twilight. Of these two, only one event has even the possibility of being seen, and that's on January the 9th, tomorrow at 5 o'clock. And as our guest speaker said, we have cloud filters the next couple of days, so I don't know that we're going to see that one. And unfortunately, there's some other things coming up that we may not see, but at least you can say that you knew about it. And another click, please. The rings are opening after around Thanksgiving. They were at their thinnest for us. And now with the planet beginning to tilt, with its southern hemisphere showing us more and more, the rings will begin to open. You can see between the two that one is February 1st, what it'll look like. You can see how much they will open up over the period of a few months. Not spectacular, but you can definitely catch that with your telescope. All right, next. So Jupiter will be at opposition on January the 10th, and 2 nights from now. It'll be brilliant. If you haven't taken notice of it already, it's in the east, magnitude minus 2.7, 46 arc-second disk in the constellation of Gemini. So when you look up and you see Jupiter, the 2 stars to the upper left of it are Castor and Pollux. Always a very dynamic atmosphere with Jupiter. Lots of belt zone storms and color changes can be seen, sometimes changing from week to week. On the 17th and 19th, it will pass half a degree north of Delta Geminorum, which should be a really cool kind of binocular thing if you don't have a telescope. Next. If you do have a telescope, one of the coolest things I think is to be able to see the Great Red Spot. These slides go out onto our website, so you can also find this information in a lot of different places like Sky and Telescope. But you can see that just about every other night you can get out there and see the Great Red Spot. And definitely could see it even with probably like a 4-inch telescope. Next. And then finally, we have a special alignment here coming up with Jupiter and the Sun and the Earth. And the geometry will be such that a lot of times the moons will pass in front of the planet, called a transit. You'll usually be able to see the moon if you have a good telescope, but definitely see the shadow. However, right at opposition, the planet, or the moon rather, is actually going to be covering the shadow. So it's going to create some very interesting, somewhat rare appearances. Click. So on the 10th at 3 a.m., Callisto, which is a dark moon and its shadow, you can see there on the left-hand side. So normally the shadows are round and very dark, like a paper punch. This one is going to be oblong. So that's going to be a very weird looking transit. The next night at 4:30 in the morning, these are early morning things, Io will be kind of like almost have a crescent shadow because the moon itself will be overlying its own shadow. Very unusual and requires certain special alignment. Like I said, maybe we'll get lucky and the clouds will disappear, but if not, look for it in Sky and Telescope and online. A little plug for Alpo Astronomy if you are interested in planets. We have more information about that. Particular event there.
All right, great. Thanks. And that's one of the websites that Jim helped develop. Talking about websites. Well, thank you. That was great. Okay, so we only have a few, but the theme is tiny moons. This doesn't quite match the Hubble discoveries of these moons, but Steve, are you online?
Yes, I am. Yeah, I with my 14-inch Celestron, I decided to try looking for the faint moons as much as I can. So far I've gotten 31 of them, and that's about all that's possible. This is Amalthea Jupiter 5, which is very close to the planet, so without using an obscuring disk or something like that, it's pretty hard to pick up, but I did manage to get it the other night.
Awesome. Awesome.
And then Helene is even harder, even with the rings not quite so bright. It's still tough to pick out some of these moons that are very close to Saturn, and this is Helene, which is Saturn 12. It's 18.6 magnitude.
Wow.
But clearly it's there. You can
Wow.
see it.
That's incredible.
And last night, I believe I was able to pick up an Enki, which is Jupiter 12 and is 19th magnitude, but I have to have another clear night to confirm it. And that's the problem with doing this, is that you don't get clear nights one after the other in order to be able to confirm the observations.
Right. Oh, well, that's really cool. Thanks. And then we've got Ken in the room with another tiny moon.
Near Age, the second moon discovered of Neptune, back in 1949 by Gerald Kuiper, the guy that the Kuiper Belt's named after. Was discovered in Texas at McDonald's Observatory by the 81-inch, 82-inch telescope, something I should look through. It has a really elliptical orbit. It goes like from 3 million to 800,000 miles around in about a year. And you can see it up there, right? It's 19th mag, it was 18.7 when this was taken. And it's actually my 35th moon that I've imaged. And the only thing I'm sad about is I didn't start earlier, because Neptune and Triton on the lower left was probably going to cross that galaxy a little bit farther.
Oh, yeah. Oh, that's so cool.
But it's a faint one up there. And it's amazing when you do this, how many asteroids are 19th magnitude in the field of view. And it's hard to, sometimes you get excited and it's like, oh no, that's not where it should be. And it's this weird 18th magnitude asteroid.
Nice. Nice. You guys with your 14-inch scopes, you can really get some good stuff. Thanks for sharing that. And then we have some going to the other extreme. We have a few C-star images. Michael, are you on?
I am, Victor. Yeah, so this is the Triangulum Galaxy M33. And for the past 2 years, I've pretty much just only been using my S50 C-Star. I had about 10 hours of data, but it did its own processing, came with a little over 8 hours. And I thought this was really, really good. I mean, this is straight from the C-Star. I didn't do anything else. I was really, really pleased with that.
Incredible, these little guys. And then see, is this the fireworks galaxy?
It is. And I had last done fireworks with my Newtonian. I was able to spot one of the supernova differences over the few months. This is again with the C-Star, just a little over 2 hours of time as well.
And then this is pretty amazing.
Yep. So this was mid-December, just a little under an hour. Horsehead and Flame. I just did that again last night with my C-Star, and again I'm just really, really pleased with its overall performance. All the processing here, all the stacking is with the C-Star.
Did you have to put a filter on the front of that?
No, it comes with its own light pollution filter, but nothing extra.
So it's not a hydrogen alpha filter.
No. And like I said, just if you look at my background right here, this was last night for about 40 minutes or so. It was a little clearer last night than it was with the image I sent you.
Really cool. Amazing. Thanks for sharing those.
Yeah, thank you.
And that is it. That's all we've got for tonight. So I want to say, as my last meeting host as president, thank you. I've had a ball, and I really enjoy everybody in this club and what it does. And thanks for making HAL great. Yeah.
Yeah, so, Wayne thanked, everybody earlier. And, I can tell you, from experience that being president of HAL is, it's a responsibility, and Victor's done it for 3 years. And he's done an excellent job, and he's grown with it and everything else. And, it's really very much appreciated, because we all benefit from the work of Victor and the board and all the volunteers. So I want to, on behalf of the council.
Thanks. And as long as we're sharing the love, Phil was president for 4 years before me, so we should thank him too. Okay, so I think we have a few minutes before we need to vacate the Robinson. So does anybody have any other questions for Faith?
No.
Oh, we got one more. We got one more hand.
If you had to take an estimate, not an exact number, but an estimate of how many human beings are currently involved in flying the Hubble Space Telescope, and then in the data reduction specific to the mission, from an order of magnitude perspective, is it 500? Is it 5,000? Is it 50? Do you have a sense of that?
I'd say it's probably in the hundreds. I'm trying to think, because there's the NASA side, and then you also have like the institute side, which does the science operations, and that I'm a lot less sure about how many folks they have there that are Hubble focused. But based on the what we have at NASA, I would say probably like a couple hundred.
Thank you.
Mm-hmm.
The Institute's at least a couple to 300 also.
Have a nice day.
In line with that question, I saw an article where NASA is gonna lose like 500 people in the near future. It's not related to, I don't have the article in front of me, but it was just last week. Anybody from Hubble affected by that?
Not that I know of. I mean, of course, you have the usual like retirements and stuff, but I don't know that anybody that we're losing anybody from Hubble, especially because the funding is still there for the mission and isn't changing. And again, I don't know if it's changing or if that's on the Institute side, like their Hubble science operations, it could be, but at least not on the NASA end that I know of.
Well, I think I'm gonna, if there's no more questions, I think I'm gonna end the meeting recording. and then we can just sort of kibitz here in the room a little bit. If we could again, just say thank you to Faith. I really, really appreciate it.
Yeah, thank you again for having me. It was great to talk to you all tonight. Thanks for inviting me to your meeting, and it's great to still see so much interest in Hubble even after 35 years. So.
Yeah, it's here. We're all trying to emulate it. We do a lot of astrophotography. You didn't see it tonight, but there's a lot of astrophotographers in the club, and so Hubble's like our hero. So
I'll say mine too. It's Hubble's older than I am, so it's been around my whole life, and so I've grown up with it. It was while I was at the Institute while I was at the Smithsonian in 2015 at that internship, I actually got to take a field trip to Goddard, and that was kind of like a well, maybe one day moment. And so then, not even 10 years later, ending up here was really, really cool.
Yeah, Hubble was up there for your whole life, and we have some other members that Hubble was alive during theirs. So
The original,
All right.
the original Hubble.
All right, I'm gonna